Hello students, welcome to the maths class. Today in this video I am going to explain exercise 8K of differentiation. In this exercise you are going to study logarithmic differentiation. First of all, I will tell you what is logarithmic differentiation. So listen carefully. The process of taking log before differentiation is called logarithmic differentiation. One more time I am telling to you, the process of taking log before differentiation is called logarithmic differentiation. Now question comes in the mind, in which type of questions we have to take log before differentiation. So I will tell you, you see here. Suppose that you are having variable to the power variable, x to the power x or x to the power y. Such type of expressions you want to differentiate. So in this type of expressions, before differentiating you have to take log, or we can say in other words function to the power function, function to the power function. So in such type of questions you have to take log before differentiation, then you have to differentiate. One more form is there, you can see UV form. UV form differentiation you know very well. U same differentiation of V plus V same differentiation of U. I told you U same differentiation of V plus V same differentiation of U. And U upon V form, this differentiation also I told you. What was the differentiation of U upon V form? It was d upon dx of U upon V square in denominator, V same d upon dx of U minus U same d upon dx of V. This was the differentiation. But students, if in UV form or U upon V form, if some difficult expressions are given, what I told you, if in UV form or U upon V form, some difficult expression in terms of x, some difficult expressions in terms of x are given, then to differentiate such type of expressions, such type of questions, we have to take log before differentiation. Then it will be easy for us to differentiate. Now through some questions I will explain this concept. So I'm taking some questions of exercise 8K. You see carefully, then you will understand. So question number 1 of exercise 8K, you can see this is UV form. Here first term you can take as U, and second term which is in product you can take as V. So UV form is given, some difficult expression is given. So before differentiation I will take log. Before starting the solution I will tell you, whatever expression is given, whatever expression you want to differentiate, you suppose that expression as y. So that's why I have written let y equals x square plus 2 whole power 3 into 1 minus x cubed whole power 4. Now taking log on both the sides. When you take log, so log y equals log of given expression, you can see. Now laws of logarithm you have to remember, which you have studied in class 9th. I am telling you one time, log mn. What was this? Log m plus log n. Like this you can apply log m upon n, log m minus log n you can apply, and one more log m to the power n equals n log m. This power will go behind the log, and log n log m you can write. So such type of laws I will apply here. In one question I am telling to you, in other questions you have to understand yourself. So you can see log mn, log m plus log n. Now third rule, third law, 3 power will go behind the log, 3 log x square plus 2, 4 log plus 4 log 1 minus x cube. Now you differentiate, differentiating with respect to x. So differentiation of log y, 1 upon y for log y, because it is not x, so dy upon dx. So differentiation of log y, 1 upon y dy upon dx. Now differentiation of log x square plus 2, 1 upon x square plus 2, and differentiation of x square plus 2 again you will do, that will come in multiplication. So differentiation of x square is 2x, differentiation of 2 is 0, it is constant. In the same way, plus 4 same, because it is constant. Differentiation of 1 minus x cubed, 1 upon 1 minus x cubed, multiplied by differentiation of 1 minus x cubed. So differentiation of 1 is 0, differentiation of minus x cubed minus 3x square. So finally by simplifying you are getting 1 upon y dy upon dx equals 6x upon x square plus 2 minus 12x square upon 1 minus x cubed. Now 6x common you can take, and this y you can take in RHS. So that's why I have written 6x into y in bracket 1 upon 1 plus x square minus 2x upon 1 minus x cubed after taking 6x common. So now you can put the value of y. I have put the value of y inside the bracket. I have taken LCM. Now you can see this 1 power will cancel. X square plus 2, here 3 powers are there. In denominator 1 power is written. So 2 power will remain in numerator. In the same way, 1 minus x cube whole power 4 is given in numerator. 1 power is in denominator. 1 power you can cancel. So 1 minus x cubed to the power 3 will remain. Inside the bracket, after simplification, 1 minus 4x minus 3x cubed. So final answer is 6x into x square plus 2 whole power 2 into 1 minus x cubed whole power 3 into 1 minus 4x minus 3x cubed. So this is the final answer. Some more questions I am taking. Question number 5, you can see this is u upon v form, and here u is the product of two expressions, v is the product of two expressions. So first of all I have taken given expression as y. Now take log y equals log of given expression. Now you apply law of logarithm. So log x minus a plus log x minus b, numerator you can see. First of all log numerator minus log denominator. Now numerator is the product of two terms, so product can be written as sum, as a sum of log. So log x minus a plus log x minus b. In the same way, minus log x minus b minus log x minus q. Now you differentiate 1 upon y dy upon dx. 1 upon x minus a is the differentiation of log x minus a. Now into 1 also I have written. So differentiation of x minus a is 1, because differentiation of x is 1 and differentiation of a is 0. In the same way, other differentiation I have written. 1 upon x minus b is the differentiation of log x minus b into 1. So 1 upon x minus p into 1, 1 upon x minus q into 1. Now you can take this y in RHS. So y into, in bracket, 1 upon x minus a plus 1 upon x minus b plus 1 minus 1 upon x minus p minus 1 upon x minus q. Put the value of y. When you put the value of y, you will get x minus a into x minus b upon x minus p into x minus q. Bracket starts 1 upon x minus a plus 1 upon x minus b minus 1 upon x minus p minus 1 upon x minus q. This is the final answer. Now question number 9, you see different type of questions I have taken here. X to the power sin x. You suppose this expression as y. Take log both the sides. Log y equals log x to the power sin x. Sin x will go behind the log, so it will give sin x log x. Log y equals sin x log x. Now differentiate both the sides. Log y differentiation 1 upon y dy upon dx. Sin x same, differentiation of log x uv. uv I am applying here. So log x differentiation 1 upon x plus log x same differentiation of sin x cos x. Simplify sin x upon x plus cos x log x. Take y to RHS. So it will come dy upon dx equals, you can see, y into sin x upon x plus cos x log x. Value of y you can put x to the power sin x, bracket start sin x upon x plus cos x log x. This is the final answer. Now question number 13 you can see. Same type question, 10 to the power cos x. So cos x, it is cos x. Y equals 10 to the power cos x you have supposed. Take log both the sides. Log y equals log 10x to the power cos x. Cos x will go behind the log. So cos x log 10x. Now differentiate. 1 upon y dy upon dx. It is the differentiation of log y. Cos x same. It is written. Log 10x differentiation is 1 upon 10x. And differentiation of 10x is sec square x by chain rule. Plus this time log 10x same. And differentiation of cos x is minus sin x I have written. Now cos x upon this sec x can be written as 1 upon cos square x, and tan x is already in denominator, minus sin x plus minus minus plus minus minus sin x log tan x. Now you can see y you can take from LHS to RHS. So y into bracket start cos x cos square x, tan x you convert sin x upon cos x, and this second term is same, sin x minus sin x into log tan x. So this cos square x and cos x they will cancel. I have shown you. So what will remain? Value of y you can put outside the bracket, tan x to the power cos x. Inside the bracket 1 upon sin x will remain. 1 upon sin x is cosec x minus sin x into log tan x. So this is the final answer. You can see this is the final answer. Now one more question I am taking. Question number 17, cos x to the power x. This time very different question it is. Very different question. Why you have taken cos x to the power x? Now this angle to the power given means this is not cos x to the power x. It is not cos x to the power x. Here power is given of angle. Power is given in angle. So directly you cannot take log, because both are different thing. This is not cos x to the power whole power x. So this is not equal to cos x to the power x, not equal to. So that's why I have taken y equals cos x to the power x. Now again I have supposed u equals x to the power x. Now here I will take log. So log u equals x log x by log law. Now differentiate this log u with respect to x, 1 upon u du upon dx, as differentiation of log y 1 upon y dy upon dx. In the same way, differentiation of log u 1 upon u du upon dx. Now x same differentiation of log x is 1 upon x. Log x same differentiation of x is 1. So you can take to RHS. So u into 1 plus log x. Value of u you can put x to the power x 1 plus log x. Now y has become log cos u, because x to the power x you have supposed as u. So y equals cos u. Now you differentiate this function with respect to u. So it will give dy upon du equals minus sin u. And value of u again you can put x to the power x. So it will become dy upon du equals minus sin x to the power x. Now how can we find dy upon dx? So dy upon dx, dy upon du multiplied by du upon dx. Okay, this is the rule I told you in previous exercises. So dy upon du is minus sine x to the power x, and du upon dx also you have found x to the power x into 1 plus log x. So this is the final answer. So such type of expressions, how to differentiate, I have told you. Now one more question you see, question number 21, important question. Y equals x to the power x to the power x to the power x to the power x till infinity. It is given, you can see. You have to prove that dy upon dx equals y square upon x into 1 minus y log x. How can we prove? Such type of question in previous exercise I told you. One more time you see, y equals x to the power x to the power x to the power x till infinity, it is given. I told you, if in from an infinite series, if we delete one term, then also it is infinite series. So if I remove this x, you see this one only. Pay attention on this one. Is it the value of y or not? Exactly, it is the value of y. X to the power x, x to the power x, x to the power x. So in place of this, I have put y. You can see here. Now take log both the sides. So when you take log, so log y equals y log x. Now differentiate 1 upon y dy upon dx. Y same, differentiation of log x 1 upon x, plus log x same, differentiation of y dy upon dx. Now dy upon dx term you can take on one side. 1 upon y dy upon dx minus log x dy upon dx. In RHS y upon x only. Dy upon dx is common. So 1 upon y minus log x into dy upon dx equals y upon x. Now take LCM. 1 minus y log x upon y dy upon dx equals y upon x. So dy upon dx will come. Take cross multiplication, y square upon x into 1 minus y log x, which was to be proved. So like this you can prove. So easy question it was. In when we were seeing this question, it was looking difficult, but you see, so easily we have found differentiation. Now question number 25 I'm taking. This is the last question which I'm taking. In this exercise I think 25, 26, 27 questions are there. So this 25th question I'm taking. Find dy upon dx x to the power y plus y to the power x equals c. This is also a different type of question. Here I have taken u equals this first term, v equals this second term. So u equals x to the power y, take log both the sides, log u equals y log x. Differentiate both the sides with respect to x, 1 upon u du upon dx, y same, differentiation of log x 1 upon x, plus log x same, differentiation of y dy upon dx. Take u to RHS. So it will come x to the power y, y upon x plus log x dy upon dx. X to the power is the value of u. I have put directly value of u. First I took u in RHS and I have put the value of u also, x to the power y, bracket starts y upon x plus log x dy upon dx. It is already given in the previous step. Now I have taken second term as v equals y to the power x. Again take log v equals x log y. Differentiate both the sides, 1 upon v dv upon dx, x same, differentiation of log y 1 upon y dy upon dx. Log y same, differentiation of x is 1. Take v to RHS and write the terms of RHS same, x upon y dy upon dx plus log y. Value of v you can put y to the power x, bracket start x upon y dy upon dx plus log y, it is same. Now you can see it was given x to the power y plus y to the power x equals u. X to the power we have taken u, y to the power x we have taken v equals c. Now differentiate both the sides with respect to x, du upon dx plus dv upon dx equals d upon dx of c. C is constant, so its differentiation will be 0. So next step, I have put the value of du upon dx, dv upon dx. I have found this one, and differentiation of c is 0. You can C. Differentiation of C is 0. So here now you simplify. First I have multiplied inside the bracket. You can see I have taken the terms having dy upon dx together and the terms without dy upon dx on RHS I have taken. Now dy upon dx is common, so inside the bracket this will remain, and here this will remain by taking minus. So dy upon dx, you take this product term with the dy upon dx in RHS, so you will get the final answer. This one you can see the calculation in the solution I have done here. So if you see properly, then you will get the this calculation. So like this, students, you can solve remaining questions of exercise 8K. You can do remaining questions of exercise 8K. I hope you have understood all the questions which I explained in this video. If you have any doubt, then you can ask. So thank you and have a nice day.